All right, hey guys, welcome back. Today we are going to learn a little bit about trigonometry and some machine shop math. All right, so the first thing you're probably wondering is you're like, hey, this is manufacturing, this is machining, why are we going to learn about some math? The reason for that is we have to know all of our values for what we're making, all right? And sometimes all of our dimensions are written out like this, right? But sometimes they come in the form of an angle. All right, so we can't really tell what the value of this point is right here, but they're giving us clues based off of this angle right here, and then other points on my triangle. All right, so if you see, if I were to trace these points, I have a triangle. All right. So there's a triangle there. There's a poorly drawn triangle by me. So there's one. And then two, down here, there's actually a second one in this part. And hopefully we've seen this part before. We've used it a lot. But you can see there's another triangle down here. So instead of giving us values at this point for our x and y, our point for our x and y here, and our x and y point for here, they give us an angle. So it's our job to decipher what that means, all right? So you can see here's 30 degrees, here's 40 degrees. They range from whatever your measurement is, all right? So if you used SOHCAHTOA, sine, cosine, tangent before, you used trigonometry before, you have a little bit of a head start. But if you've never done it before, that's okay. We're going to start breaking that down today, all right? So I'm going to scroll over to a blank page where I have SOHCAHTOA, all right? So this is just helping us find the angles and help us find what angles and what sides we use in order to figure out our dimensions and our values, all right? So first things first, these only work for triangles that have a right angle. And that's 90 degrees. That's that. If you see this box right here, that means it's 90 degrees. It's perpendicular. It's a right triangle. Okay? And then the next thing I have to figure out, if I have a right triangle, is I have to figure out where my angle's at. All right? So I'm just going to use, let's say it's this triangle. All right? See how this triangle is a right triangle? And I have my 30 degrees. Right here's that angle. So I'm going to project that over here, and I'm just going to say, hey, this is 30 degrees. All right? You can make up whatever number you want right now. It does not matter. We're just using an example problem. All right? So I want to label, because this is manufacturing, I want to label my x and my y axis. So x is over here, and y is on the left. All right, so I'm going to label my x and y axis, and later on we'll give these values when we're figuring things out. All right, so I have my x and y, and then I'm going to label this long side. This is called our hypotenuse, so I'm going to label that h. Okay, so I have my triangle labeled now. Now I could start to figure out what value I'm looking for. So if I'm looking for my x value, okay, you can see I have H up here, but I have O and an A. So O stands for opposite, and then A stands for adjacent. Adjacent. So what that means is my opposite is whatever value is across from my angle. All right, so if I'm looking for my opposite, I'm looking for whatever value is across from my angle. All right, so if I were to go right now, here's my 30-degree angle in this point. My opposite would equal my y-axis. All right, so whatever it is directly across. Adjacent is whatever it's touching. All right, whatever it's touching. So adjacent for here, my 30 degrees is touching my x value, so I know then my adjacent is my x-axis, all right? And this completely changes if I were to have an angle up here. Now my y-axis is touching, so my y-axis is adjacent, which means that my x-axis would be my opposite, excuse me. My x-axis would be my opposite for this green arrow, all right? So that just changes depending on where that angle that we're given is at, okay? Or the angle that we're trying to find. So, I'm gonna go back to red. Now, what I can do is I can look at it, all right? And let's say, hey, I'm trying to find my y-axis. Let's say I'm trying to find my y-axis right now, okay? So I'm gonna move this up here just as a reference for us. Move that over here as a reference. Now I have this whole area to work. So I just made up that I'm looking for my y-axis, all right? Let's say that I do not know my y-axis, all right? I know that my y-axis is my opposite, all right? So my sine, before I even get to that, I have to figure out what operation I'm gonna have, all right? So let's say that I'm given my hypotenuse and my angle, all right? For this example, I'm given my my value here. Let's say that's 10, okay? I just made that up. It's just a nice round number. So I'm given my hypotenuse, I'm given my angle, and I'm looking for my y-axis, all right? I know my y-axis is my opposite. So if I have my angle and my hypotenuse, and I'm looking for my opposite, so opposite equals question mark, I'm going to look at my values, all right? My cosine is my angle, all right? Adjacent and hypotenuse. Do I have my adjacent? No. So I will cross out, cosine for right now. Let's look at tangent. Tangent, I have my angle, so that's the T or the S or the C. I have my tangent. I'm looking for my opposite, all right? So that's good that we have our opposite here, but I don't know my adjacent. I'm not looking for my adjacent, so this is bad. I don't want to look for my tangent. Now let's look at sine, all right? Oh, sine, I have my angle, all right? I'm looking for my opposite, and I have my adjacent, I have my hypotenuse, and that's 10. So what I'm going to do is I'm going to use this equation. And if I were to break that down, it's just sine of 30 degrees, because I have 30 degrees, so sine 30 equals my opposite, which I don't know, so I'm just going to put a question mark. You could put an X like you do in algebra. This is our Y value, so if I wanted to put Y to keep it easier, I might do that, all right? So I'm looking for my Y-axis, so I'll put a Y here, over my hypotenuse, which is 10. 10, right? So now, whatever my sine 30 equals is the same as my Y value over 10. So if you remember from algebra, what I'm going to do is I'm going to multiply this side by 10 so I can multiply the left side by 10. Remember, so this is equal to 10 over 1. These cross each other out. So that way I'm given 10 times sine of 30 equals Y. All right, now we're able to figure that out. Okay? After I do that, I can find my value. So I'm going to pull out my phone. If you rotate your phone like this, you can see I have sine, cosine, and tangent. All right? So if I do 30 sine, I get 0.5, and now I'm going to multiply that by 10, and I get my Y value is equal to 5, right? So all I did in my calculator is I did 30 times sine, and then I multiplied 10 after. and I got equals 5. So now I know my value, instead of a question mark for my y value, is actually 5. All right? So that's briefly how we do it. If